We're ready to take a look at number 3. So we have a random sample of 6 music students who played a short song, and the number of mistakes in music each student made was recorded. After they practiced the song 5 times, the number of mistakes each student made was recorded. Using a 10% significance level, test the claim that on average, there is a decrease in the number of mistakes made for students after practicing the song 5 times. All right, so we'd like to know if practicing improves their performance here, so they make less mistakes. And I've gone ahead and entered my subjects before number of mistakes in L1, and each subject's number of mistakes after practicing. And I'll go ahead and put those differences in L3. So if you want to pause for a moment and get that data into L1 and L2, and then we will go to our L3 and enter the differences between those matched pairs. So each subject is a pair, and I'll record here the differences. So we could just do 4 minus 3 ourselves, of course, but we're just taking advantage of the calculator here. So just jotting down those differences. All right. So with matched pairs, we have to do a little bit more thinking in terms of writing our hypotheses. So if our difference is the number of mistakes before minus the number of mistakes they made after practicing, so our claim that there's a decrease in the number of mistakes. So if the number of mistakes is smaller on averaging after they practice, so that would mean that the number of mistakes before is the larger number minus the number of mistakes after practicing. If the claim is true, that should be a smaller number, less mistakes. And a larger number minus a smaller number is always a positive number. So I would expect on average that the differences would be positive. Okay, and just kind of looking at this, for the majority of my students, the difference was positive. I have one student here that actually made more mistakes after they practiced, so that's interesting. So the idea is, if we average all of those numbers, would we have evidence that the difference for a population of people that practice would be a positive difference? Okay, so positive numbers, right? Positive numbers are numbers greater than 0. I just like to write it in English here. So the claim with that on average, the differences between the matched pairs would be a number greater than 0. All right, so we always have to be careful with matched pairs because the claim is there is a decrease in mistakes. So there's a temptation to put less than here because it says decrease. But with matched pairs, you have to go through this thought process to figure out if that difference, we're expecting it to be a positive number or a negative number. And we're going to do a two-tailed test in a moment, but we've got a right-tailed test now. So our null hypothesis would be that the differences would be 0. In other words, that practicing would make no difference. Okay, so that's sort of the hard part, thinking that through, getting our hypotheses correct. And then we'll take advantage of technology and do the p-value method. So we run a regular t-test. So I'll do a t-test where my input will select, we have the data. And our data, let's get to the calculator here. So stat tests, t-test, we switch ourselves to input data. And then for the list where we have our data, just make sure you switch that if it doesn't say it already, you want to switch that to L3, our differences. So L3, all right, frequency always stays 1. And then the direction of the test, we want mu greater than our mu naught number. And I forgot to change my mu naught. Sorry, mu naught is 0. So maybe I could actually throw that in here too. So with matched pairs, we're always having a mu naught of 0 there. And then I'll do calculate. All right, that p-value is 0.0884. So 0.0884. I prefer to write that as a percent, 8.84%. And we compare that to the choice of alpha, and alpha was a 10% significance level. So 8.84% is smaller than 10%. Technically, we say less than or equal to, but it is smaller. And then we're back to our rhyme. If the p-value is low, lower than alpha, if the p-value is low, we let the null go. So if the p-value is low, the null must go. So we know we're going to reject the null hypothesis. And as always, when we reject the null, we are supporting our claim, because our claim is our alternative hypothesis. So we would say that there is enough evidence to support a claim that practicing will decrease the number of mistakes on average. And this will be for population. So for all students who practice, we think on average, the mistakes that they make will decrease. All right, we'll do one more here. So in our next example, all right, so a researcher wants to compare the resting pulse rates of identical twins to see whether there was any difference. So 9 sets of twins were randomly selected. The rates are given in the table below in beats per minute. So each pair of twins here, so those are matched pairs. At a 5% significance level, is there evidence of a significant difference in pulse rates of twins on average? All right, so I know we've been putting things in L1 and L2, and then our differences in L3, but I just want to point out here that we could skip that part and just do the differences ourselves, especially because these are whole numbers. It's just really easy for me to just do it here quickly on my own. 91 minus 93 is -2. 92 minus 95 is -3. So we're just subtracting here the twin A pulse rate minus twin B pulse rate, and -2 there. 88 minus 86 would be 2. This one is -1. That one is 0, no difference. 93 minus 86. I'm just grabbing my calculator, save me a little mental math right now. So that's 7. And then 87 minus 83 would be 4. So you could just do that on your own. And then it just saves me a little typing on my calculator. Now I could just put all those in L1. So I'm just clearing my calculator out. And I'm just going to enter those differences myself. So rather than having a calculator find the difference, you could just do it yourself. So I should have 9 numbers there. -2, -3, -3, -2, +2, -1, 0, 7, 4. And just double checking for typos. All right. So let's get our hypotheses written. So let me address here the claim that's being made. So the claim we're testing Is there evidence of a significant difference in the pulse rates? So in this case, we're not saying that we think one twin's pulse rate is higher than another or lower than another. We would just like to know if there's evidence of any difference. So if the pulse rates on average are different, then all I can say here is that you're not going to have 0 on average as the mean difference. So now we don't have the detail of thinking the difference is positive or negative. We just know that it's not 0. Because if the pulse rates were the same, the difference would be 0. Otherwise, it would be some non-zero number, perhaps negative, perhaps positive, but we're just interested on average. Will the difference be some number that's not 0? So will the pulse rates not be the same? So this is our two-tailed test. So this is a little bit easier. We don't have to think quite so much when it just says, are we looking to see if there's a difference? All right, and then the null hypothesis will be our equal. All right, so now to do our p-value, I decided just to put all my differences in L1. So I'm just going to switch that back to L1. And then we pick our not equal to, so our two-tailed test, the pulse rates different on average. And then calculate. And this is actually a very big p-value, 0.8518 or 85.18%. The alpha was 5%. So that p-value is certainly bigger than the alpha. All right, so the rhyme is, if the p-value is low, let the null go. But the p-value is not low, it's big, bigger than alpha. So if the p-value is not low, we do not let the null go. So we do, that looks weird. The decision is do not reject the null hypothesis. Okay, and as always, if you don't reject the null, then you don't support the claim. That was our claim. So at least based on these 9 twins that were in the study, I'm going to say that there is not enough evidence to support a claim that there's a difference in resting pulse rates among twins.